This theory is applicable only for single electron species. Single electron species. Remains silent for multi-electron species. Remains silent for multi-electron species. Okay. All the formulas, everything what we have done is applicable only for the single electron species, not for the multi-electron species. This theory does not explain Z-man effect.
Sir, can you scroll up a bit?
What?
Can you scroll up a bit?
Yes, the
Thank you, sir.
done. This theory does not explain Z-man effect and Stark effect. This theory does not
So,
explain Z-man effect and Stark effect.
yes, done.
This theory does not explain Z-man effect and Stark effect. What is Z-man effect? What is Z-man's effect? The splitting of spectral lines in presence of magnetic field in different direction. The splitting of spectral lines in presence of magnetic field in different direction. So an spectral line gets split up into different directions when magnetic field is applied. When magnetic field is applied. This theory does not explain this thing. Splitting of spectral lines in presence of magnetic field in different direction is Z-man's effect. He was a scientist, Z-man. He has seen this effect, but it was not explained by the Bohr model. Stark effect. Stark effect, Stark effect, splitting of spectral lines in presence of electric field. Electric field. This is Stark effect. Stark effect. Electric field. Splitting of spectral line in presence of electric field is called Stark effect. Okay. Am I audible?
Yes, sir.
Yes, sir.
Just scroll up a little bit. Okay, sir, done.
This theory does not explain the doublets of spectral lines observed in the spectrum. Doublets means two lines were exactly similar. So such two or three doublets were present. That doublets, why do we have such doublets of spectral lines that has not been explained by Bohr theory? If this is the spectrum that you are getting, some doublets were occupied, or sorry, observed. Some doublets were observed. Two lines which are exactly same. Others were different. But some doublets were observed. Such doublets were not explained by this Bohr theory. For example, we are getting like this. So those doublets were not explained by Bohr theory. You have to remember this line only because the spectra is not there in NCRT, not in your course also.
Sir,
Spectral lines, yes.
what does not explain means? Means it is not proved there. Like that.
See, when we have got the spectra, we have tried to explain why we have such lines, right? So two lines were exactly similar, exactly similar. They look like the you can say like they are exactly similar. There is no difference between them, like twins. Such spectral lines. Why we are getting such spectral lines? That was not you can say explained by the Bohr theory. So that becomes the drawback. Otherwise,
Same
we have explained the full spectrum.
So same with Zeeman effect and staff effect, no?
That was the, yeah, it means that only, it does not explain. But Zeeman effect is what? The spectral line gets splitted into different directions in magnetic field. Okay, does not explain का मतलब यही है that this theory remains silent about that thing. ऐसा क्यों हो रहा है उसको नहीं पता है, उस चीज को एक्सप्लेन नहीं कर सकते. Sania.
Understood, sir.
Okay. Madhura, can you speak up?
Yes, sir.
Yes, what you are saying?
No, sir, I got it.
Yeah. Spectral lines are the lines which finally we got in the emission spectrum.
Yes, sir.
Emission spectrum में आपको बना के दिखाया था black background with bright lines, which is showing that those frequencies were absorbed by the electrons of atom, and when they come back, those energies has been released. वो जो लाइंस मिलती हैं उससे जो आपका स्पेक्ट्रा बनता है उसको स्पेक्ट्रल लाइंस बोलते हैं.
Yes, sir, got it, sir.
ओके,
Thank you.
व्हाइट लाइट इज कंप्लीटली डिफरेंट. ठीक है, व्हाइट लाइट हमें कंटिन्यूअस स्पेक्ट्रम में मिलती है जब हम सनलाइट पास करते हैं. दैट टू इट इज द इंसिडेंट रेडिएशन. ओके,
Yes, sir.
एनी डाउट इन दिस?
No, sir.
Aradhya, it can be related to that, but actually it is the cathode ray tube. Aradhya,
Okay.
the
CRT
old
TV.
TVs are those are cathode ray tubes. You can relate that thing because वहां पर भी we have a stream of electrons. Electrons are moving from cathode to anode, and we do apply electric and magnetic field. But
Yes,
in
sir.
one word, it is a cathode ray tube. The old TVs were cathode ray tube. ठीक है, उस टाइम पर no one was knowing about the spectral lines and all. But as of now, if we conclude with everything we know, then we can say there also we have electrons, there also we have magnetic and electric field. So we can have Siemens and Stargate. Understood?
Okay, sir.
Somehow related. Write down dual nature of matter. Dual nature of matter. Dual nature of matter. Can we start it?
So is this a new lesson?
No, not new lesson. Lesson start होगा तो मैं आपको बता दूंगा. In
Okay.
the starting only, when I started this chapter, I gave different subtopics. In that, after Bohr model, we have dual nature of matter or de Broglie equation.
Okay, sir.
Okay, chapter start होगा तो I'll let you know. मैं बता दूंगा मैं. Subtopics of the same chapter. Can we start now? Hello.
Yes, sir.
Yes. As we know, electron has both the character that is wave nature, wave nature wave nature, and particle nature. As we know, electron has both the characters, that is wave nature. Wave nature we have seen in Bohr model. We have calculated frequency, wavelength, all those things. And obviously the spectrum we are getting. Particle nature, where energy has been transmitted from photon to the electron and electron becomes free. Particle nature is shown by photoelectric effect. As electron has both the characters, that is wave nature and particle nature, so matter which is composed of electron only should also have
Please scroll up.
what you are saying, Abhyal, I didn't get you.
Sir, please scroll up.
Yes. Done?
Done, sir.
All of you done? As electron has both the nature, that is wave nature we have seen through Bohr model, particle nature we have seen through photoelectric effect, matter which is made up of electrons only should also have dual nature. Okay?
So what does dual means?
Dual means
Double,
मतलब both. दो
double nature.
डबल नहीं, डुअल नहीं, मतलब डबल नहीं, डुअल मतलब बोथ, दोनों.
Okay, sir.
दोनों के लिए डुअल वर्ड यूज किया है. ठीक है, डबल तो हो गया 1 into 2. इट इज लाइक इट हैज बोथ द कैरेक्टरिस्टिक्स, इट हैज बोथ द नेचर्स. ठीक है, किसी सेम चीज को दो बार मल्टीप्लाई कर देना इज कॉल्ड डबल. बट अगर दो दो कैरेक्टरिस्टिक्स है तो उसको बोलेंगे डुअल.
Understood, sir.
या
So dual is not two, no then?
डुअल इज बोथ.
Okay, sir.
यस,
I got
टू
confused.
आप बोल सकते हो बट दीज टू आर डिफरेंट थिंग्स. इट्स नॉट 1+1, it's 1 and something.
Okay, sir.
All of you understood?
Yes, sir.
ठीक है, मान लो आपको फिजिक्स और केमिस्ट्री दोनों आता है तो आप उसके लिए बोथ यूज करोगे ना, डबल थोड़ी यूज करोगे.
Yes, sir.
Relation between wave nature and particle nature of matter is given by or discovered by de Broglie. De Broglie, because of its spelling, अदरवाइज उनको डेब्रॉय बोला जाता है, डेब्रॉय। ठीक है, स्पेलिंग से आप उसको डी ब्रॉगली भी बोल सकते हो। ओके,
So that is LIC or E?
LIE, डी ब्रॉगली।
Okay, sir.
Yeah. And relation is called de Broglie equation, and relation is called de Broglie equation. Very simple topic, very short topic, बहुत छोटा सा टॉपिक है, बहुत सिंपल टॉपिक है, बोर मॉडल ऐसा नहीं है। मे बी विल कंप्लीट दिस चैप्टर टुडे ओनली, मे बी। All of you written it? All of you have written it? Yes, sir. All of you. Just wait a second. Just a minute. Yeah. How he discovered the relation? He has taken Einstein equation, E is equals to mc square, shows particle nature. Shows particle nature. Einstein equation shows particle nature. Okay. And Planck's equation, wave nature. Wave nature. He has taken both the relations, Einstein equation which shows particle nature and Planck's equation which shows wave nature. Okay, he equated both of them or compared both of them. So mc square is equals to hc by lambda, where c is what? Where c is what?
Constant.
Very good constant.
Speed of light.
It's speed basically, right? Velocity, or you can simply say speed of light. Okay, so this can get cancelled out. Lambda will be equals to h upon mc. Any doubt in this?
No, sir.
No, sir.
Any doubt in this? Now, if we do not have light, if we have some particle, then C can be replaced with V. Yes or no? इफ वी डू नॉट हैव लाइट, लाइट नहीं है हमारे पास, तो इलेक्ट्रॉन है, तो इलेक्ट्रॉन की स्पीड तो स्पीड ऑफ लाइट नहीं होगी, इट विल बी सम अदर स्पीड. फॉर एनी particle, lambda will be equals to h upon mv. What is mv? mv is momentum. mv is momentum. So lambda is equals to h upon p. Any doubt to anyone in this? Any problem to anyone in this?
So what is P?
P is momentum.
And mv is also momentum.
P is a donation. हम डिनोट कैसे करते हैं, राइट? जैसे हम स्पीड को v से डिनोट करते हैं, या वेलोसिटी को v से डिनोट करते हैं, फॉर एग्जांपल.
Both
ओके,
mv and
मास को
P
m से
represents.
डिनोट करते हैं. या p is equals to mv it is.
Okay, sir.
Okay, p is equals to mv. I thought you are knowing it. That's why I didn't write it. No, p is equals to mv where it is momentum. All of you understood?
Yes, sir.
Okay. So this is momentum, particle nature, and this is wavelength, wave nature. Hence, wave nature and particle nature are related. Hence, wave nature and particle nature are related. Understood?
Yes.
All of you understood this?
Yes, sir.
Copy fast. E is equals to hc by lambda. What we can say, if lambda, or I can say if mass increases, mass increases, is the screen visible?
Yes, sir.
Yes, sir.
If mass
Yes, sir.
increases, then wavelength decreases. Mass increases, then wavelength decreases. If velocity increases,
Sir, you're muted, I guess.
okay, I'll just make changes. Just wait a second. Do not do all these things यार. इससे time waste होता है. Am I audible?
Yes, sir.
Yes, sir.
Yes, sir.
This theory is applicable for microscopic particles only. This theory is applicable to microscopic particle only because they will have observable wavelength. They will have observable wavelength. Okay, if you take the electron, proton, alpha particle, if you take such small particles, there only you can find out the wavelength and you can see it. But if you take any macroscopic particle like a car, you cannot see its wave nature because its mass is very, very high. So its wavelength will be very, very small. You won't be able to see it. Understood?
So can you please elaborate of how mass matter is also wave? So because a wave is
Again,
also
what?
particles. So no, I did not understand how matter can be wave, because a wave is also a particle only, na, going up and down,
You are
vibrating.
talking about mass or the particle?
Matter, so matter, sir.
Matter. So what I have said is that electron, I have said that electron has both the natures, wave nature and particle nature. Understood?
Yes, sir.
This we have done in the previous classes. Bohr model is all about the wave nature. We have calculated wavelength in so many cases. When electron was moving from one orbit to another orbit, and when it was coming back, it was giving radiations, right?
Yes, sir.
And in the particle nature, we have seen that it is taking energy from light and then getting ejected out. That means it is showing the conservation of energy. Okay, which is a form of particle nature. Collision is taking place between. Photon is colliding with the electron. That way it is showing particle nature. Any doubt in these two lines?
Sir,
Just wait a second, Sanya.
Sir, but
Aradhya, huh.
sir, but how can matter be a wave, sir? Like a wave of what it is?
Okay, which matter you are talking about? You are talking about the
Sir.
matter which surround us.
Yes, sir.
हाँ, तो उसी के ऊपर ये theory है. This theory is explaining that particular thing. कि why you cannot assume that matter is a wave, because हमारे आसपास जितनी भी चीजें हैं, whatever the things surrounds us, those are macroscopic particles. उनका मास इतना ज्यादा होता है that we cannot see its wave. और
Okay, sir.
इलेक्ट्रॉन जो है that is a microscopic particle, उसका मास इतना कम होता है that we can see its wave. That is why you can assume, हाँ सर इलेक्ट्रॉन का वेव तो हो सकता है, लेकिन मेरे आसपास ये जो बेंच रखा है, can you show its wave nature? तो मैं उस बेंच का वेव नेचर नहीं दिखा सकता. क्यों? क्योंकि जो आपका बेंच होगा उसका मास होगा 200 ग्राम 300 ग्राम, which is not at all accepted. क्योंकि अगर आप उसका वेव निकालोगे, वेवलेंथ निकालोगे, it will be beyond that you can see it. इसीलिए इट इज नॉट एक्सेप्टेबल. और उसी के ऊपर ये थियरी आई है that this theory is applicable all the microscopic particles, इलेक्ट्रॉन, प्रोटॉन, न्यूट्रॉन, जिनका मास 10 to the minus 27 होता है, 10 to the minus 31 होता है, 10 to the minus समथिंग 20s के अंदर आता है, वहां पर तो हम देख सकते हैं.
As per his theory, even a proton can be a wave, and even a boson.
Yes, definitely. If it
Okay,
is a
sir.
particle, it can act as wave. If it has mass, then we can find out its wave nature also. Okay.
But it's a wave of what? It's like wave of what is going up and down? Like what
The
of what?
particle only. The particle only
particle.
moving. Yes. I'll show you that also. I'll show you that how Bohr model and his theory are correlated. I'll show you that also.
Okay, sir.
Yeah. Sania.
Sir, microscopic particles we cannot see, right?
Yes.
Then how can its wavelength be observable?
See, we cannot see does not means we cannot see it with the naked eyes. है ना? अगर आप माइक्रोस्कोप यूज करोगे, we will be able to observe the pattern. आप तो बायो के स्टूडेंट्स हो, आपको पता होना चाहिए. So whatever the things are going on in bio, they are related to or they are seen through the microscope only.
Yes, sir. So it depends upon its mass. You just previously said.
I have said that if the mass is very less, you will be able to see the wave nature of those particles. If the mass is very high, then wavelength will be will be very less, and you won't be able to see it. Okay,
Okay, sir.
I'll take one example also to make it clear. Okay. आराध्य, you understood this? ये theory आप ही की बात को justify कर रही है कि
Yes,
this
sir.
theory is not applicable for the macroscopic particle. It is only for the microscopic particle. अगर आप बोलो कि सर मेरी कार खड़ी हुई है, आप मुझे उसमें वेव नेचर दिखा दो, तो I won't be able to show it. But it is applicable for electron.
Yes, sir. Understood, sir.
Yeah. All of you understood this?
Yes, sir.
All of you understood this? Any doubt to anyone? So
No, sir.
lambda is equals to h upon mv. एक एग्जांपल करते हैं so that we can make it more clear. ठीक है. Calculate the wavelength
Sir, scroll up. Okay, sir, done.
calculate the wavelength of the electron moving with 10% of the speed of light. ठीक है, try this. All of you try this and give me an answer in nanometers. ठीक है, कार ही लिख देते हैं. Anyone done? Lambda is equals to h upon mv. Lambda is equal to 6.6 into 10 to the raised power minus 34 divided by
Sir, scroll up.
point 0.41 nanometer. Into 3 into 10 to the raised power 7. Point 0.24 nanometer. Sham, recheck. 2.2 divided by 9.1 into 10 to the raised power minus 34 plus 31 minus 7. Done, Sam?
Yes, sir, done.
Okay, so it becomes minus 41 minus 10.
So the speed of light should be 3 into 10 raised to 8, right?
Yeah, but I have taken only 10% of that.
Okay.
You didn't listen that? आपने देखा नहीं वो? It's only 10% of that. It's 0.24. 0.24 into 10 to the raised power minus 10 or 0.024 nanometer. Okay.
Sir,
Yes.
sir, we have to by heart all these values 6.6.
These values are generally given in the exam paper. But अभी
Yeah.
टेस्ट में तो नहीं आएगा. Yeah. What?
So when is the next test?
That I do not have. The timetable दिया होगा.
Even the value of momentum will be given, sir.
No. Why?
I just
Mass
didn't
of electron, or velocity of light. All the constant values are always given in the question paper, in the main question paper.
So isn't there any shortcut value so that we can find only the constants and then we can replace it with, and then we can multiply the variable. So like we can find
But that will
h upon m first.
but that will keep on changing ना. मैं आपको बता दूं. But मान लो क्वेश्चन इलेक्ट्रॉन के लिए नहीं आया, प्रोटॉन के लिए आया. Then it will get changed ना. आराध्य.
Okay.
If
Yes,
you
sir.
want, we can keep one value for electron. मान लो इलेक्ट्रॉन के लिए क्वेश्चन नहीं आया, प्रोटॉन के लिए आ गया. Then you cannot keep that h by m. You have to change it.
Okay, sir.
Yeah.
Understood.
Sanya,
So it will
understood?
be given. No, sir, not properly.
What you are not
Just
getting?
how did the values come? Because it is taught previously, so I didn't got that.
Okay, so h is 6.6 into 10 to the raised power minus 34 joule second. Mass of electron is 9.1 into 10 to the raised power minus 31 kg. Velocity of light is 3 into 10 to the raised power 8 meter per second. Okay. Or 27.
So all this will be given, or we have to sum of
Which
this.
values?
All
This
three will be
value,
given. Yes.
this will be given in the main exam. जब आप main exam में बैठोगे तब ये given होगा. ऐसे टेस्ट के अंदर
By
नहीं
heart
आती.
all this.
हाँ, आपको याद रखनी पड़ेंगी. You have to do practice on this. Okay, because generally जब main exam आता है, there is a separate page for all the constants. First page, all the constant values are given, which you can use. Okay.
So
लेकिन
this
वो main
V
exam
is
में होगा.
10%. This V, the velocity of light is you have written is 10%.
Yes, in the question we have taken only 10% of it.
The full value will be given.
Yes.
Yes, now understood. Thank you.
Okay. All of you understood this?
Yes, sir.
So Aradhya, this angstrom and nanometer, these are observable values. हम wavelength generally इसमें निकालते हैं. So these are observable. But if I try for car, if I try for car, कार का मास मान लेते हैं 200 kg और उसकी वेलोसिटी मान लेते हैं 100 मीटर पर सेकंड. ठीक है, just to get the difference, try to find out wavelength for this. Try to find out wavelength for this.
So scroll up.
Yes, Aradhya, find out the wavelength of car.
Yes, sir.
That's what you're talking about, right? So we are trying it for a macroscopic particle. We are trying for macroscopic particle. Do it fast. 3.3 into 10 to the raised power minus 38. Lambda is equals to h upon mv. It's 6.6 into 10 to the raised power minus 34 divided by 200 into 100. So as you are saying, it is 3.3 into 10 to the raised power minus 38. This is not at all observable. Understood, आराध्य? मैक्रोस्कोपिक पार्टिकल
Yes,
का
sir.
मास आपको ऐसे ही मिलेगा. मान लो 100 ग्राम होता तो 35 आ जाता. But we can see only picometer or angstrom or nanometer. लेकिन मैक्रोस्कोपिक पार्टिकल में हमेशा आपको 10 to the power minus 30, 10 to the power minus 40 kind of things you will get. That is why they are not observable. That is why this theory is limited to the microscopic particles.
Yes, sir. Understood.
Okay, so you can try this for proton also. You can try this for neutron also. You can try this for neutron, that alpha particle also. You will get observable wavelength. लेकिन अगर आप क्रिकेट बॉल के लिए निकालोगे, बेंच के लिए निकालोगे, किसी भी चीज के लिए निकालोगे, which have mass in grams, which we generally have, in that case you will get values 10 to the power minus 35, minus 33, minus 34, which are not at all observable.
Yes, sir. Understood, sir.
Yeah. All of you understood this? ठीक है, एक और रिलेशन देखते हैं. All of you have done it?
Yes, sir.
If we are, it's not possible now because I am the one who is the presenter here. Now no one can mute you. Please copy it fast. Done. All of you have done?
Yes, sir.
Okay, तो एक क्वेश्चन देखते हैं. Find the ratio of wavelength of proton and alpha particle if their momentum are same.
The 1:1 ratio.
Very good. So lambda is equals to h upon p. Lambda of proton divided by lambda of alpha particle is h upon momentum of proton into momentum of alpha particle divided by h. As they are same, answer will be 1:1. Any doubt?
No.
Sania done?
So can you explain it again? How
I
can
have said,
all the values be equal?
see h is always equal. h तो कांस्टेंट है, वो तो इक्वल होगा ही.
Yes.
और क्वेश्चन में दिया हुआ है मोमेंटम आर सेम,
Got it, sir.
है ना. If the velocity of particles are same, if the velocity of particles are same, इस बार मोमेंटम नहीं दिया है, velocity दी है. If the velocity of particle are same,
Just scroll up.
Sam, you understood the previous question?
Yes, sir.
You never give answer for anything, yaar. If you want, I can wait, but do not rely only on the copying the notes. ठीक है, आप क्वेश्चन भी करो. Sakshi is saying 4:1. Yash is saying 1:4. Rishikesh is also saying 1:4. Sanya done? wavelength of proton divided by wavelength of alpha particle will be h upon mass of proton, mass of alpha particle divided by h. We know mass of alpha particle is 4 times the mass of proton. So it will be 4:1. Sanika, how it's 1:4? Rishikesh, how it's 1:4? Sanya, I'm not done. Am I audible to all?
Yes.
Yes, sir.
किया
Yes.
नहीं यार?
So I didn't knew that statement.
Okay.
Mass of lambda is 4 times. I was absent during previous classes.
No problem. Rishikesh, question will be exactly the same I have given. So that is not a mistake. Right? उससे आपका आंसर गलत हो जाएगा. Whatever is written before, whatever it is in afterwards, take only that two. You cannot take the ratio of it of your own because दोनों options given होंगे. ध्यान रखना इस बात को, दोनों ऑप्शन गिवन होंगे. 1:4 भी होगा, 4:1 भी होगा. All of you done? Can I give you next question?
Yes, sir.
Yes.
Find the ratio of wavelength of A and B if momentum of A is 50% more than momentum of B. If velocity of A is 20% less than that of B. C. If mass of A is 25% more than B and velocity of A is 25% less than A, sorry, B. Yes, for which question you gave answer? A का सनिका 1/2 कैसे? Sanika, how you got 1/2? Sakshi and Rishikesh are getting 2:3. Sanika and Yes are getting 1:2. What about others? 92 स्टूडेंट्स हैं, 2 स्टूडेंट आंसर कर रहे हैं. Who got 1:3? 3:2. Different answers are coming.
So can you just read the B statement?
B's velocity of A is 20% less than that of B.
What is that? Then what is the
Then that of B. A की velocity 20% कम है B से. Tanya.
understood, sir?
Okay. तो देखो, momentum of A is 50% more than that of B. If momentum of A is x, if momentum of B is x, if momentum of B is x, then momentum of A will be 50% more. It will be 3x by 2. Any doubt in this? Any doubt in this? X plus x by 2. 3x by 2. Any doubt in this? So lambda of A divided by lambda of B, h upon P of A, h upon. Sanya, please mute your mic.
Sorry, sir.
PA will be 3x by 2 and P will be x. X से कट जाएगा. 2:3 is correct answer. 2:3 is correct answer. Two is to three is correct answer. Yes, understood. Madhura, Spara, Sanjana,
Yes, sir.
Madhura, understood. Spara, understood. चलो नेक्स्ट देखते हैं. This was A. B. What is given? Velocity of A is 20% less that of B. let the velocity of B is x, then velocity of A will be 0.8x. 20% less. So lambda of A divided by lambda of B is h upon h m into V of A
So how
divided
is
by
that
m.
0.8x? How is that 0.8x?
20% लेस x का 20% क्या होगा 0.2x
Yes, sir.
and that much has been less तो x में से 0.2x माइनस कर दो 0.8x बच जाएगा
Okay, sir, understood.
या h से h कट गया m से m कट गया this will be x upon 0.8x that will be 5 by 4 second answer is 5 by 4 किसी ने 4 by 5 तो नहीं दिया 5 by 4
Again.
please speak up again I didn't hear
So today explain it again. The
I have
second
said
part.
velocity of A is 20% less than velocity of B. Okay. So let velocity of B is x. Then what will be the 20% of x? That will be 0.2x. This much we have to subtract. तभी तो less होगा. So it will become 0.8x. Shifa,
Yes, sir.
understood?
Yes, sir.
You know what Yash is saying. We have assumed the mass of A and B in case of B. Yes, yes, that's what maximum we can do because no other information is given. Shifa understood?
Yes, sir.
Then just put the values. We will get 5 by 4.
Okay, sir.
Okay. C देखें. C में क्या दिया है? Mass of A is 25% more than that of B. Let the mass of B is X. Then mass of A will be 1.25x and velocity of B is 0.75 y and velocity of A is y. That's what given. Question is velocity of A is 25% less. Mass of A is more. Mass of A is more and velocity is less. So it will be 0.75 y and this will be y. Any doubt in this? Shifa, you understood this? X
Yes, sir.
1.25x, y 0.75y. है ना तो इसको रख देते हैं lambda of A divided by lambda of B is equals to x upon h mass of A into velocity of A mass of B into velocity of B. This will get cancelled out. Mass of B is x, mass of A is 1.25, mass of velocity of B is y, and velocity of A is 0.75 y. I think something is wrong in this.
Yes, sir. Their product comes about to 0.9375.
So why other students have get that? Have I done something wrong? मैंने कुछ गलत किया इसमें?
No, sir.
How much you are saying? How much it is coming?
0.9375.
Yeah, that is same thing. वो 15/16 भी उतना ही आ रहा है. Okay, Madhura?
Yes, sir. But
No,
how
sorry,
do
16 by. Again, what?
how do we identify the ratio?
It will be. You have to solve this, ना? You won't be able to solve it. इसको 1.25 को लिख लो 4/5. इसको लिख लो 4/3.
Yeah, sir. Got it.
I thought मैंने कुछ mistake कर दी. All of you understood this? All of you understood this?
Yes, sir.
Yes, sir.
ठीक है. कुछ और करते हैं. Relation between kinetic energy and wavelength. All of you completed fast. Done. Okay. So what is the formula of kinetic energy?
Half mv square.
Half mv
Half
square.
MVC.
Kinetic energy is half mv square. If we multiply both sides by m, it will become 1/2 m square v square equal to kinetic energy into m. Right? If we take this to the side multiplying both sides by m, so 2m kinetic energy is m square v square. If we take the square root on both the sides, it will become mv is equals to 2m into kinetic energy. Any doubt in this?
No, sir.
And we know that lambda is equals to h upon p.
H upon P.
So lambda will be equals to h upon root 2 m into kinetic energy. Okay.
Yes.
All of you understood this?
So please scroll up. Okay, sir.
Okay. Kinetic energy of a accelerating charged particle is equals to Q into V. Q into V, where Q is the charge and V is the potential applied. It is the formula. Okay. So I can say that lambda is equal to h upon root 2 m into charge into potential. Any doubt in this?
So can you repeat?
I have said that if a charged particle is accelerating, then its kinetic energy will be equals to the charge on the particle multiplied by the potential applied to it. जो इलेक्ट्रिसिटी आप प्रोवाइड कर रहे हो उसका जो पोटेंशियल होगा, if you do q into v or the charge into the potential, you will get the kinetic energy of the electron or the particle. Are you getting it?
Yes, sir.
देखो अगर हमारे पास ऐसे ट्यूब है, गैस ट्यूब, and you have electrodes here. Let this be negative. Let this be positive. And a charged particle is moving in this. Charged particle is moving in this. तो इसकी kinetic energy, इसकी velocity depend करेगी how much electricity you have applied to it. How much electricity you have applied to it. If you apply very high electricity to it, very high potential you apply, it will move with high kinetic energy. So its kinetic energy, its movement, its velocity will depend upon कि उसके पास charge कितना है और उसमें potential कितना apply किया है. Okay, Sanya.
So they are proportional, like that.
What?
So the potential energy and kinetic energy is related.
It is the potential, the voltage you are applying, not the potential energy. Voltage, जो घर के अंदर इलेक्ट्रिसिटी आती है ना, वो वोल्टेज अप्लाई आप कर रहे हो, ये बैटरी है.
The voltage is more than the kinetic energy is more.
Yes, more voltage you apply, more positive it will become, more positive it will become, more attraction will take place, more speed it will move.
Got it, sir.
Okay, so kinetic energy will be charged into potential.
Understood, sir.
Understood? Yeah. Sam, you have some important work, you can leave. Okay. Particles can be electron, proton, or alpha particle. Okay, so their masses will be different. Their formula will be different. Understood?
Yes, sir.
Okay, we'll continue from here tomorrow.
So on Saturday we start new lesson.
No, no, we have Heisenberg uncertainty principle, and I'll give you some formulas for this also. No?
Okay, sir.
One class more is required.
Sir,
Okay, sir.
Yes.
Thank you.
have you earlier
You're
taught
welcome.
us taught SP students about conductivity?
No.
You are going to teach.
Why don't you need conductivity?
No, I have just saw that you are going to teach it today in
Actually,
class
that is by
11.
mistake. नहीं वो मैंने गलती से ना 12th में लिखना था 11th में हो गया है 11th और 12th की जो टाइमिंग है ना वो स्वैप हो गई है इसलिए वो दिखा रहा है
So can you tell me? So the portion of
Thank
SP
you,
and
sir.
class 11 is same, or just it is ahead, or
it is completely different, not ahead, not behind, completely different.
means you
Different
have
things we need in 12th class.
no, only in 11th class, class 11th and this SP. We have two groups, right?
Again, what?
I am joined in two groups, class 11 and
Oh,
SA. So it
this
is
is ESIP. Okay,
coaching
okay,
classes and this integrated classes. The portion is
okay.
same. I just
Portion
want to
definitely will be same. Yes, portion will be same.
know
More
when you have
practice.
started teaching, it is slightly behind.
Okay, okay, that way. I think they are
Yeah.
moving ahead. They are moving ahead.
So they are moving ahead means you are going to teach. So
Means
you are going to teach you what they have earlier taught.
in coaching classes.
Yes. I just
Definitely,
got
I'll teach.
confused. I just really got confused because you have not taught us that.
Okay, do one thing. You just leave this class as of now, and I'll call you separately. Then we'll talk about it. Okay? नहीं तो ये फिर class के अंदर
No,
जाएगा.
sir, my doubt has been cleared.
Okay then.
Thank you, sir.
Mm.
Thank you, sir.